Welcome to my channel once again. In today's topic, we'll be talking about electrolysis. What is electrolysis? Electrolysis is the chemical decomposition of a chemical compound when the direct current is passed through solution of the compound or its melting state. So in electrolysis, what happens? There's a decomposition of these substances known as electrolytes. This brings us to what is known as terms in electrolysis. The common terms we're going to encounter during this lesson. We're going to talk about electrolyte. We're going to talk about electrolyte. We're going to talk about electrode. About the electrode, we're going to talk about anode, the anode and the cathode. We're going to talk about so let's end this way so that we'll explain each of them properly. We said electrolytes. Electrolytes, these are substances that conduct electricity. Electrolyte can be weak or strong. They can either be strong electrolyte or weak electrolyte. What I mean by weak electrolyte, these are substances that dissociate completely in a solution. A very good example is salt solution, acids and all. So we'll talk about weak electrolyte, we'll talk about those ones that do not dissociate easily, completely in a solution. A very good example is ethanoic acid. Ethanoic acid, they conduct electricity, but they do not dissociate easily. So the conduct of electricity is not as is low compared to strong electrolyte like salt solution. So talk about electrode. Electrode are in form of wire through which current enters or leaves the system. So we have two types of electrode in electrolysis. We have the anode and the cathode. The anode is a positive electrode. The positive electrode. While the cathode is what? Is a negative electrode. So to move on to this, throughout this topic, we're going to talk about what is known as ionic theory. Talk about ionic theory. Ionic theory. A scientist known as Arrhenius gave us an idea on what happens when an electrolyte is dissolved in water, or melted in water. So the Arrhenius in 1887 stated that when an electrolyte is dissolved in water, some, if not all, of the molecules of these electrolytes, they dissociate themselves into a free-moving ions, into a free-moving particles called ions. These ions, these are the ones that conduct this electricity because they move around the system. So what happens when an electricity is passed through electrolysis? What happens, for instance, now let's use an acid to explain this concept of ionic theory. So when this acid is dissociated in water, so when it is dissolved in water, this solution will break down into two parts, positive plus SO4, 2 minus. So in this aspect, we said when electricity is passed through this H2SO4, it breaks down into two parts. We have the ions and the negative surface. So what happens in this aspect is that when a current passes through these substances, it breaks down into two. So we have the cathode, and the what? And the anode. From our term that we explained, this is a positive, this is positive, this is negative pole. Let's use for instance. So what happens during an electrolysis? If an acid is involved in this electrolysis, we said this acid will dissociate into two parts, the positive and the negative. In this aspect, what happens to this point? We are going to have hydrogen ion SO4 2 minus. What happens in this environment is that these ions will be attracted to each of the poles. For instance, the negative ions will be attracted to positive, so the SO4 2 minus will be found in this pole. So within the system, we will have hydrogen ion attached to this pole. So what actually happened in this aspect is that whatever that is found at the cathode in chemistry, they are known as what? All the ions that are found in this cathode are known as what? Cation. They are known as cation. So in other way, positive ions are known as cation, while negative ions, since these negative ions are found at the positive pole, it is called anion. Anion. In other way, any positive ions, any negative ions, they are known as what? Anion. Negative ions. A negative ion are what? Positive ions. So I want to draw your attention to this point is that students do make mistake on how to quantify or how to know the difference between an electrode, a cathode, or an anode. So when you make reference to cation and cathode, they get confused on what to do. In electrolysis, the cathode is a negative pole, while the anode is what? Is a positive pole. But when we talk about ions, we talk about cations are the positive ions, while the anions are the negative ions. So how can you make reference to this? For you not to be confused, just ensure that whenever a substance on an electrolyte passes through, when the current is passed through them, they dissociate into two parts. They dissociate into an ion, a positive one and a negative one. So you just draw out your pole. This is just a negative. Negative is the cathode. Negative is the cathode, while the positive pole is the anode. So what positive, you understand that positive and positive, they will repel each other. They will repel. They will not attract each other, but opposite charges, they attract to each other. So in this aspect, all the positive ions will come this way because this is the negative pole. So all the negative ions will be found here. So this pole that contains all the negative ions, since it's found at the anode, it is now known. We'll take two letters from here, and we add the ion in it to form anion. So here that have the positive, since they are found at the cathode, we bring out the CAT, we add the ions. So in electrolysis, the cathode is a negative pole, while the anode is what? Is a positive pole. When we talk about ions, cations are the positive ions, while the anions are the what? Are the negative ions. So this moves us to what are the factors that affect the discharge of electrode of these ions in electrochemical system. What are the factors that affect the discharge of ions? So we are going to move to a topic known as electrochemical series. Electrochemical series. Electrochemical series. For you to understand this topic properly, you must understand this table properly as a student, so that to know when a given substance, when a given reaction is possible, when it's not possible. For instance, now, this table shows us what is known as electrochemical series. If you check this table, they are arranged according to their reactivity. According to their reactivity, how powerful they are. For instance, now, if you're having ion in a solution, for instance, now we have like sodium chloride plus ion for an instance. For an instance, it means that ion cannot displace this sodium. This ion cannot displace this sodium because ion here is lower at the electrochemical series. For instance, now, this means, let's use our family anarchy. So you are the eldest atom, and you have a very younger one atom, a young one atom. Your young one atom cannot just walk into you that, Mr. Ben or brother Tari, go and buy me rice. You feel embarrassed, and you might actually smash such child. So that bring that knowledge to this aspect, that whatever that started this electrochemical series is higher in anarchy in this their reactivity. We have potassium, sodium, magnesium, aluminum, zinc, iron, and tin, lead, and so on and so forth. So as you come down this table, their reactivity is what is reducing. So for instance, now we have the higher one as potassium ion. Potassium ion is very reactive. So when you have a compound, for instance, now when you are dealing with a displacement reaction, when you see something that have to do with potassium, for instance, now you have something that can do with potassium. Let's say potassium oxide. Say you want to react with zinc oxide, for instance, zinc oxide. You ask yourself, or you want to react with only zinc. You realize that this kind of reaction will not be able to take place because this oxygen, this potassium cannot release this oxygen to this zinc because it's lower in the electrochemical series. So what am I trying to say? These ions are arranged according to their reactivity. According to their reactivities, this part of these ions, as I've said, they are known as cation ions. They are known as cation ions. So here you come to the negative side of the table. These ones are known as anion because they are what? They are negative. They are negative. So fluorine is stronger than sulfate. Sulfate is stronger than nitrates. Nitrates is stronger than chloride. Chloride are stronger than bromide. Bromide are stronger than iodide. This iodide to what? Hydroxide. If you should check this table, this fluorine can display anything here in a given reaction. That is to say, if there is any compound that any foreign particles that is attached to all these ions, fluorine can discharge any or display any of the particle present. So, students, you have to understand this electrochemical series so that electrolysis will be very, very easy. Very, very easy. So, for instance, we're going to talk about electrolysis of substances. For example, during the course of this lesson, you're going to be engaged with electrolysis of substances. Like one, I'm going to talk about electrolysis of brine. Electrolysis of brine. I'm going to talk about electrolysis of acidified water. Acidified water. Theory, I'm going to talk about electrolysis of copper sulfate. In these 3 steps, I'm going to discuss each of the steps in each of the